Hi everyone, and welcome to today's lesson on the quadratic formula and the discriminant. Now by the end of this lesson I'm really hoping you'll understand pretty much what it says on the screen. The following, know what the discriminant is and know how to use it to find the number of solutions of a quadratic equation. Now the discriminant's actually really simple. It is in my view. It's one expression and basically, I'll tell you now, b squared minus 4ac. Well, spoiler alert, sorry, that's the way it goes. But it builds on what we've done previously, and we've looked at the idea that we can solve quadratics by using the t method or by completing the square. And in every single case, to be able to use the tools that we have available to us, we have to use ax squared plus bx plus c. Now it's got to be equal to 0. Why? Because when we make it equal to 0, we're finding specific crossing points on the x-axis. That's why it's equal to 0. Otherwise, to be honest with you, all we have to do, or all we can do, is just complete the square or put it in factorized form. Now, we know, because we've had a bit of a chat last lesson, about the specifics of the quadratic equation. And if you remember, when I was a kid, we had to memorize this in year 7. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And if we didn't know it, we walked into our lessons and had a rather large book banged on our heads. But the point of it is, this plus and minus sign is really important. We've learned that for quadratics, the most solutions, the most times it's going to cross my x-axis is 2. So here's a recap. The number of possible solutions. Here is a quadratic equation. There's two different examples. First one is it's crossing in 2 places. The first one we can see here is minus 2, 0 and 3, 0. That's specifically where it crosses. And we know that when we're doing these, we're trying to find 4 pieces of information. X-axis intercepts, y-axis intercepts, and turning point. Now that actually only makes 3 pieces of information, but if I include the x-axis as twice, that's fine. So that's where it crosses in 2 places. And remember, with quadratics, all we're doing is moving them around just so that they touch the x or y-axis in different places. Now here it crosses in just 1 place. Crosses at the point 2, 0. Now, again, it's called a repeated root. There are actually 2 solutions. The point of it is there's actually the same number twice. So we say it has 1 solution. And realistically speaking, with this example here, all I've done is I've taken my standard quadratic, if you remember, it's just a parabola, and we've moved it 2 places to the right. What about when it doesn't cross at all? Well, hopefully it makes sort of sense that, yes, if we move the parabola up and up and up and up and up, and ooh, fabulous shadow on my face, then it's going to get to a point where, like here, it has a turning point and it will have a y-axis intercept, but it doesn't cross my x-axis. And in this situation, we say there are no solutions. But let's just look at this quadratic equation through what I call a new lens, which is quite funny because this is the first video, once again, I've come back onto the camera. So if we look at that quadratic formula, we see something that's actually probably the most important. This b squared minus 4ac under that square root sign. Now let's go back to maths we've done previously. We've had examples where we've known for completing the square that if I had the square root of 4, I'm really happy because it can be 2. It can be plus and minus 2. Remember, minus 2 squared is actually 4, and 2 squared is also 4. So, square root of 4 is awesome. 2. Square root of 0 happens to be 0. But if I try and put into my calculator the square root of minus 4, it doesn't work. It doesn't work in mathematics in year 10. It works much later on when we get to specialist maths in years 11 and 12. But at this moment in time, if you look at what the idea of a square root sign is, and I say a square root is when 2 numbers multiply itself, do we get the number under the square root sign? Well, is there a number multiplied by itself that can give us negative 4? And actually, it can't. Well, that's interesting, because what that would suggest then is if this value here, this b squared minus 4ac, turns out to be negative, then we can't solve it. And ka-ching! Ladies and gentlemen, there we go. When b squared minus 4ac is negative, and I'm going to write that as less than 0, we now know there are no solutions. Woo! But what about taking that idea further? Is this b squared minus 4ac thing really important? Yes, it's the discriminant. Don't tell anyone. Well, let's look at what happens if b squared minus 4ac were equal to 0. So again, I'm going from x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And what am I doing now? I'm saying, well, what happens if I let this equal 0? Well, looking at the algebra, there it is. Well, we know the square root of 0 is 0. Putting it down to this section here, we got minus b plus or minus 0. Well, hold on a moment. If I add 0 on or take 0 off, I'm going to get exactly the same value. I'm going to get the same answer. So, ladies and gentlemen, it turns out that I get left with this plus or minus 0 disappearing and just minus b over 2a. Well, if the plus and minus has disappeared, there's only one solution. And when b squared minus 4ac is equal to 0, then actually we get that one solution. So if we go back to my example here, my one solution, whatever the equation was here, whatever the ax squared plus bx plus c was, when I did the b squared and I minus the 4ac, I would have got a value of 0, which then gave me this 1 point. And then what about the last part of b squared minus 4ac? Well, we've met that lots and lots of times before. Again, just writing it out, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. If this value here, this b squared minus 4ac, is greater than 0, this plus and minus kicks back in, and I will get two solutions. Wow, this stuff is flipping awesome. So when we combine the rules, and this is maybe that thing where you sort of take a screen grab or download my PDF that comes with this, which is just the notes, then we actually have this. B squared minus 4ac greater than 0. Now that greater than 0 actually also can just stand for the keyword positive. And in methods 1 and 2 and 3 and 4 and A levels, that greater than 0 sign also means positive. And it's always useful to know that. When b squared minus 4ac is equal to 0, we have that one solution. And where it's less than 0, otherwise known as negative, then we have absolutely no solutions. Now, maths being maths, ladies and gentlemen, we like to have certain symbols. And what it turns out is that discriminant has its own symbol, and it is this wonderful triangle. So again, all I've done here in the screen, as you can see, is this triangle is greater than 0, 2 solutions. Equal to 0, 1 solution. And less than 0 is no solutions. In all of these cases, please just remember that this is nothing more than you trying to find out how many crossing points there are on the axis. All right, so find how many solutions you'll get when solving the following quadratic equation. Well, let's just make one out. Let's say 2x squared minus 3x plus 7 equals 0. How do we do this? Well, all I'm interested in is the question says how many solutions will I get? I'm looking at b squared minus 4ac. That will tell me how many solutions I've got. Right, so my a value is 2, my b value is minus 3, and my c value is 7. Well, substituting those in, then b squared is minus 3 squared minus 4 times 2 times 7. Well, minus 3 squared is 9, minus 4 times 2 is minus 8, minus 8 times 7 is minus 56. And actually, believe it or not, I don't really care about what the physical size of that value is. What I can now see is if I do 9 minus 56, I'm going to get a negative value. And if you remember, I cannot do the square root of a negative number. And so, because b squared minus 4ac is less than 0, I can now say there are 0, and I'm going to put that in brackets, solutions. Brilliant. Now actually, in many cases, we can use b squared minus 4ac to help us before we even solve questions. Wouldn't it be nice to know up front that actually something's not going to solve, rather than waste 15 minutes on a test? 15 minutes? Who takes 15 minutes on a test to actually do these things? All right. Special note, when that discriminant is 0, we end up with what we call a perfect square. Now, look at this one example below here. We've got x squared plus 6x plus 9. If we work out what b squared minus 4ac is, well, b is 6, a is 1, and c is 9. And what we find out is that when we do 6 squared minus 4 times 1 times 9, we get this 0 value. And so that would mean that if I was to actually take x squared plus 6x plus 9 and complete the square in the way that I do it, half this middle term and square it. When I square plus 3, what do I end up with? I end up with 9. So actually, I don't need to put any number on the end of there. I don't need to add or minus anything because actually I've already got that plus 9. So I suppose you could say that in the absence of any number there, what is written here is a perfect square. Finding the axis of symmetry, when looking at the case when the discriminant is 0, we came up with a wonderful solution. This one here, x equals minus b over 2a. And actually it's really, really important because this here is called the axis of symmetry, or at least it helps us find the axis of symmetry. Now, you're talking about what's this axis of symmetry? If we go back to the general idea of a quadratic, and I'm just going to draw a general quadratic, the great thing that we know about it is actually it is symmetrical. Wow. So the left-hand side and the right-hand side will look exactly the same. And it just so happens this axis of symmetry goes through my turning point. And because it goes through my turning point, the x-coordinate of my turning point, if this was, for example, 3, 0, this x-coordinate here absolutely happens to be my axis of symmetry. So if I'm getting this right, this would suggest that if I have an equation in the form ax squared plus bx plus c equals 0, then I can happily use this to find the x-axis, to find the x value of my turning point by using x equals minus b all over 2a. Now you're going to say, well, hold on a moment, does that only work for one solution? I can only use that. No, it doesn't. It actually works every single time. It does not matter whether the graph has 0 solutions, 1 solution, or 2 solutions. By using the fact that x equals minus b over 2a, we can find the x-coordinate of my turning point. So all that work we did on completing the square, there's another way of doing this. And that's the great thing about mathematics. There are lots and lots of ways of doing things. So if I wanted to find the turning point of that equation, x squared plus 6x minus 2, then, well, we could complete the square. And I've done that there. All right, how? Well, remember x squared plus 6x minus 2. Didn't need that bracket there. Let's get rid of that for a moment. I always half my middle term, so long as that is a value of 1 there. 3 squared is 9. I don't want 9, I need minus 2, so I'm going to minus 11. Relatively quick and easy, but there's one way of doing it. So we know what our turning point is straight away. Minus 3, minus 11. That was easy. But now we know this idea of this axis of symmetry. X equals minus b all over 2a. Well, what is the value of b? B is equal to 6. A we know is equal to 1. And so when I substitute those values in, x is equal to minus b, which is minus 6, all over 2 times 1, which gives me this value here of minus 3. Well, that's awesome, because we already know from this here that using translation, the x value of my turning point is minus 3. So this can be incredibly useful. The problem is it seems like a lot of work later on, because having now got the x value, we would then need to go back and find my y value. And how would we find my y value? Yep, we would substitute it back into my original equation. So all I've done here is just said, well, when x is equal to minus 3, x squared becomes minus 3 squared. We know that 6 times minus 3, and there's the minus 2 at the end. Little bit of mathsy, and we get y equals minus 11, which is just amazing. Now, again, personal preference. Do you use completing the square? Do you use axis of symmetry? Who knows? This video, believe it or not, actually started about the discriminant, which is, if you remember, b squared minus 4ac. And why do we use it? We use it to find whether there are 1, 2, or 0 solutions for a quadratic equation. Well, it's been fun seeing you. Thanks so much. Now, if you'd like to see more, why not subscribe by clicking that little box over there, or, I don't know, load up another video. It's been great seeing you, all right? I look forward to seeing you next time.